Hi everybody. We are going to be talking about reflections with curved mirrors today. Yesterday we talked about using flat mirrors and figuring out the law of reflection with the incident rays going into the mirror and reflection rays coming back out of the mirror. Anyway, so that those two angles were always equal to each other. We won't be measuring that today. In fact, we won't be measuring that with curved mirrors, but we will understand how that they come back through with our ray diagrams. Now, so there's a couple of things that you need to draw. You need to draw a curved, and if you make this a really strong curve on this, then you're going to end up having a diagram that can sometimes run out of control. So it needs to barely be curved, and then you need to draw a normal. And a normal is this position straight out of the mirror where it is perpendicular to this tangent of this curve. Okay, so that's our normal. Okay, then I counted just 6 squares over, and you're going to have to use a ruler here, so you may need to stop and go get one. And so I counted about 6 units over, and then 6 more for this one. The focal point in the center of this curved mirror. The center of the curved mirror, of course, would be the radius, so this distance would be the radius of the mirror, and the focal point is always halfway between the radius or center and the mirror. Okay, it's exactly halfway in there. So get yourself some paper. If you have graph paper, that's wonderful, but you don't need it. Get some lined paper so it's a little bit easier to keep track of where everything is at. And get your ruler and pause it here and go get that real quick. Okay, so in our first ray diagram, we're going to draw about 4 of them, I think. In our first diagram, we're going to put the object, we call this outside of C, is not inside of C or the radius R. I tend to always call this C, but it's still the radius of it. Anyways, our object is going to be placed outside of C, and so you'll notice that it doesn't matter how tall it is. But if the higher that you make your object, your drawings can get a little bit wild. And then if it's really short, then you're going to find that you can't tell where lines are crossing for your image. So that's the whole idea, is to figure out where our image is, if it's going to be real or virtual or upright or inverted. So let's go ahead and start with our first line. Okay, here's our first line, and it goes straight from the tip of our object to the mirror, and then it bounces back, and it comes back right through the focal point every time. In fact, I gave you another sheet that tells you that the first ray always goes from the tip of the object, draw it parallel from the normal to the normal axis. It bounces back right through the focal point. The second line. Okay, the second line is from the tip of the object, and you draw it straight through the focal point, then it bounces into the mirror and off of the mirror, and then runs parallel to the normal axis. Like this. So we'll do that. So here's our second line. Okay, it goes from the tip of the object again through the focal point, hits the mirror, and then it's going to reflect off, and it's going to reflect off parallel to the normal axis. So take a moment and draw that one. We always draw three lines in most cases, in all of them but one. And then, so we've got one more, and that's to draw right straight through the curvature of, or C or R, and then straight down. And then it's going to be right at the tip of where our image is going to be. So let's do that next. Sorry. Okay, so now we went right from the tip of the object through C or R, and then look, right here is where all 3 rays converge. Converge means that they come together at that point, and I should have written that on here, but converge is where they all come to so that we can see where image is going to form. Oopsie, hang on. So our image is going to be, notice that it's not as tall as our object is, and we'll be doing the math on this stuff tomorrow, but notice that it is also upside down. And so when it's upside down, it's inverted. Inverted means upside down, but also when it is on this side of the mirror, when it's on the inside of the curve, it is also a real image. But we notice that real images are also upside down too. So real image, inverted, we have to say both those things, and you'll find that the real inverted images will always be on this side of the mirror. When we do our math, this is going to be on the positive side of the mirror. Okay, moving on. So here's where we're going to put our object right in between R or C and F, the focal point. So we're going to put our object between here, and our very first line again is always go parallel to the normal axis, right at the tip of our object, hit the mirror, and then it bounces back through the focal point. There we go. The next one, do you remember on that sheet? You're supposed to go right straight through the focal point, hit the mirror, bounce back, parallel to the axes. Normal axis, I should say. Sorry. And so let's do that. Okay, so now it's going to go back parallel to the normal. And I see an image might be forming here. Let's go and verify that with our last ray, that goes from the tip of the object to the tip of the object right straight to the through C or R, and then it keeps on going, and then you'll notice that the rays are all converging here again, and so we're going to have an image back here. Okay, there we go. Notice that this again is a real inverted image, and notice it is bigger than the original object. That always happens when we have the object is placed between these two, between F and C. And that the image, the closer that you get to the focal point, the bigger that the image will get way back here. Okay, sometimes it goes way, way, way back, and you wish that you had a bigger piece of paper. Okay. Now, also another thing about this, if you would go take this whole image and flip-flop it horizontally so that the image is right up here and the object is down here, you would notice that it would be the same as the previous picture. It's just the opposite. The geometry does that for you. Okay, so those are, the first one was an image that was placed outside of C. Now it's inside of C, between C and F. And it's really a flip-flop of the other. Okay. Oh, I'm so sorry you couldn't see this. That this is real and inverted. Sorry, I can't get that over there. Okay, so let's go ahead and look at another one, but we've started here, here, and now let's put it at F. Oh, there we go, sorry. Okay, so now our object is placed at F. So again, our rule is to go parallel across the tip of it, hit the mirror, and then go right back straight through F. Okay. Our second one, how are we going to go from the tip through F? So we can't draw that ray. Okay, and then the second one says go through the tip and go through C. This is the one special case when you will notice that you are going to have parallel lines. They are not going to converge anywhere. They're not diverging anywhere. They're not going to come together to form an image. So there will be no image with this one. It will be definitely parallel and no image. So what I want you to do here later on is I want you to take a spoon, and you're going to look at the inside of the spoon so that like your nose would be on the inside of the spoon, and there's a point where there is no image. Okay, so move the spoon away from your face and there will be no image. And then as you go and your nose moves further back, then you're going to notice a really big image. Okay, and then as you go further back with your object, your nose, you will start to see it. It's still upside down, but it'll become smaller as you move further away, and that makes sense. And it's located up here and upside down. Okay, so the question is, what happens to your nose? What does your nose look like when your object is way up here? Well, your nose looks big. Okay, so here it is. So we're going to put our object between F and the mirror. Okay, I hope that you're pausing these and drawing these out and giving yourself a little, this will be a reference sheet for everything that you need to do in the future with reflection of a curved mirror, I should say. Anyway, so let's go ahead and draw our first line we're supposed to draw. Okay, I got a problem here. Okay, so if you would go, and I'm missing a line from the tip here over to the mirror and then back. Okay, it's missing. Sorry about that. Anyway, you'll notice that these rays are diverging back here. Okay, they are not coming together. They are diverging. Diverging means that they are going apart. They're not coming together. And so what we'll notice is that they will come together over here. That makes sense. If they're going apart down here, they're going to come together over here somewhere. So this is where your nose will actually look like it's inside of the spoon. I shouldn't say that way. Your image is going to be a virtual one. It's going to be upright, and just like it was in the standing flat mirror, those are virtual images when they're upright and you can see back into the mirror. Okay. If I was going to go and have this be a candle object, it would look back into the mirror. My other objects that I have, they would shine back actually on a screen back here. So that's why they call them real. And we're not going to get into that because we're running out of time this year. But real images form on screens. And so that's, I mean, we could put a screen and we would have done that in the lab, but you can only do that in a couple spots because, you know, the paper gets between you and the candle. But anyway, so a virtual image is just a little bit different than that. Let me show you. Okay, so I'm going to extend this one. Okay, and I don't know what happened to my first original one there. And then I'm going to extend the blue one and then run it parallel, because remember, it's supposed to go through the focal point and then run parallel to the axis once it hits the mirror. Okay, and then C is supposed to go straight through F. And so these ones you need to write down on what order that they are written in, so that you get yours, so that you get your rays to converge, and so that you'll be correct at the positioning of your image. Okay, so what about when you go and you tip your spoon around? Okay, and now you're looking at the back side of the spoon, so the curve is actually, you're talking about being on the convex side of the mirror. Okay, if you have a convex mirror, they're like in grocery stores. You can see around corners with it. You can see everybody walking down the aisles because they're up in those corners. Anyway, so what happens is that you see really small people in that mirror because it's able to see a lot. This is also like the image in your passenger side of your car is also shaped like this. Images are smaller than they appear. Images are further away than they appear. Anyway, it's because it's got a you know, this type of mirror where you've got a, you know, convex mirror. Anyway, so if this was the object, all of your geometry would be showing you a smaller image inside the mirror. Okay, and it would be virtual and upright too. Oh, good, I did write that. So virtual and upright is what this is called when it is up, when it's on the other side of the mirror, just like when you were standing in front of the flat mirror. Okay. Well, that I'm sure is going to take you more than 15 minutes with all the pauses and stuff. So we're going to stop right here, and then we'll have a problem that we'll do tomorrow, and then we'll use some of the math with it. Okay? I'll see you then. Bye-bye.